This conference will now be recorded.
Very good evening, students. Today we'll start discussions on the previous year's questions from the paper JEE Main 22nd July, shift 2. This will be 22nd July actually, okay? Second shift. So let us start our discussions. This question says, what will be the projection of vector A on vector B? So first of all, if I draw this, suppose X and Y, okay, I'm just taking arbitrary vector A this way and a vector B along this way, not these vectors, okay? I'm just arbitrary drawing just for understanding. If this is theta, so projection of A along this will be A cos of theta, right? A cos of theta. And if you want to know what is the projection vector like along this direction, then you have to multiply the direction along with that, okay? So that will give you the projection vector along B, okay? Projection of A along B. Now let us consider this question. So what is the projection of A on vector this? So this will be projection of A on B vector will be A cos of theta B cap, okay? A cos of theta B cap. So this is the one. So see this cos theta, we know this theta is the angle between A and B vector. So how do we get that? We know A dot B will be mod of A mod of B cos of theta. So if we want to get cos theta, so cos theta will be A dot B by mod of A mod of B, okay? So if we put this in this answer, so we will get A dot B divided by A B modulus, and this is B cap, okay? So let us try to get what is A dot B. A dot B is, see, A is I plus J plus K unit vectors, and B is I cap plus J cap. Now I dot I will give you 1, J dot J will give you another 1. So you'll get this as 2, okay? So we get A dot B as 2. What about mod of A and mod of B? So mod of A will be square root of 3 and mod of B will be square root of 2, right? So further we have here a one a is here, so let us just strike out this a from both. Okay, so then what we get, final expression, so mod of b, this is b cap. Okay, let us write b cap, b, sorry, modulus of b. So modulus of b is root 2 actually, root 2. Okay, so let us put this here. This we get 2 divided by root 2, and further this b cap will be actually I plus j divided by root 2 again. So finally this will be I plus j. Okay, so if you look the options given here, the projection of a vector on b is I plus j. Okay, and this is on b. Okay, so option C is the answer for this question. Okay, now let us read this second question. The second question says, an electron of mass me and a proton of mass mp are accelerated through the same potential difference. Same potential difference. Okay, the ratio of de Broglie wavelength associated with the electron to that with the proton is mp by me, or 1, or me by mp, or square root of mp by me. You have to find out the correct answer for this question. So look here, whenever a charged particle is accelerated through a certain potential difference, then its kinetic energy will be K into V. Okay, so in this case, for electron as well as the proton, they have same magnitude of charge, so the energy will be, see, if I write kinetic energy of alpha particle, sorry, electron, suppose k electron, that will be half me v a square is equal to, or better to, since we have to calculate de Broglie wavelength, better to write this kinetic energy in terms of p square by 2 me, and this p square by 2 me will be is equal to E into V. Okay, and see kp, that is p square. Okay, this p is actually for, p is for electron. Okay, and this p is for proton, is equal to 2 mp is equal to ev. So this energy is same actually. All right, so now we have to find out what is p of electron. That will be square root of 2 me into ev, and here p of p will be square root of 2 mp ev. Potential is the same. So now de Broglie wavelengths, so lambda electron to the lambda p will be h by p, right? So h by p E H by PE, and here it will be PP by H. So H we can strike out, and here we'll get PP by PE. So what is PP and what is PE? So look this one, PP. So we can write 2MP into EV divided by 2ME into EV. So this EV I can cancel out, this two I can cancel out. So finally we get square root of MP by ME. Okay. So option D will be the correct answer for this question. So let us go to the next problem. This problem is very, very interesting. So problem 3 says a nucleus with mass number 184 initially at rest. Okay, suppose this is X. Okay, this has certain mass number 184 at rest, emits alpha particle. So it emits alpha particle, that means the reaction will be 180 here, and alpha particle I can write 2He4. Okay, so this is alpha particle. All right, this is the reaction, and along with that there will be some Q value generated. So if the Q value of the reaction is 5.5, so this Q value is 5.5 MeV given. Calculate the kinetic energy of the alpha particle. So I have to find out the kinetic energy of the alpha particle. So this question is very, very common and very interesting, as well as very, very important for any competitive exam. Kinetic energy of alpha particle can be asked in many ways. So look here, there are two conservation laws which we have to actually apply here. One is total energy conservation. Okay, and second thing is linear momentum conservation. Okay, so first of all, total energy is actually equal to the Q value here. Okay, total energy, if I write E total, say E total is Q value, and that will be the energy of alpha particle. This is basically the kinetic energy, alpha particle plus the energy of the daughter nuclei Y. Okay, so this is the thing. Now we'll be applying the linear momentum conservation. Look, the question is that the nucleus was at rest initially, okay, and then it emits. So suppose this was the nucleus at rest, and then it undergoes alpha decay. This is the alpha particle, and this is my daughter nuclei Y. So you look here, what happens when it was at rest, but it was at rest in the beginning, so the initial momentum will be obviously 0. And see, now after the decay, alpha particle and this particle will have, obviously we know alpha particle has certain kinetic energy, that's why the question is, so whenever there is kinetic energy, that means there will be some momentum for the alpha particle, and since there is no external force, so linear momentum should be conserved. So I can write this as P 0 is equal to py plus p alpha. Let me write the velocity of the alpha as v alpha, and for this let us write this as vy. So I can write, if I take modulus, see actually you know what will happen. So these two guys will actually move in the opposite direction, okay, opposite direction with this same momentum, okay, same linear momentum. So you know this alpha will be equal to minus of py. So they have to actually move in the opposite direction to conserve the linear momentum. Fine, if I say this has c m alpha, v alpha is the velocity of the alpha particle, and this is suppose my and vy. Let us find out what is vy. So vy is equal to m alpha v alpha divided by my. Okay, so here you know alpha particle has mass 4, mass number itself I am taking as mass, and this daughter nuclei has mass, see m alpha, this is m alpha, this is my as 180. Okay, so basically this will be 4 by 80 v of alpha. I'm not doing any simplification, I'm keeping this as it is. Okay, look now, I'll just take this energy conservation. So the Q value will be exactly equal to the sum of the kinetic energies of the daughter nuclei and the alpha particle. So half 4 into v alpha square plus half 180 into v of y square, that will be exactly equal to the Q value. Okay, now I have got vyc. From here I can actually erase this part. I have got v alpha, which I am going to use here, sorry, vy. From the conservation of linear momentum, vy I have got 4 by 180 into v alpha. This is the parameter which I'm going to use here in the conservation of energy. So other things I can clear out. Let me clean this. So look here, this I'll remove again, this boundary. Okay, so this implies, see if I take, say I need to find out the kinetic energy of alpha particle. So half 4 into v alpha square. Okay, this will be plus 1, and look, this will be 180 by 4, 180 by 4, 180 by 4. So half has come here into vy square by v alpha square. Okay, so vy square by v alpha square means what? See from here, vy by v alpha whole square, that is 4 by 180 whole square, right? I'll put it here. So this is nothing but the kinetic energy of alpha particle. This I'm keeping here, and right hand side there will be 5.5 MeV. Okay, so this term I get 180 by 4, and this will be 4 by 180 whole square, right? This equal to MeV. Okay, now look this, if we simplify, see 1 4, I can strike out this and get 1 out of this, right? I hope it is clear to you. So you can do the simplification by yourself. So this will be E alpha is equal to 5.5 into 180 divided by 184. And if you do the calculation, you will get nearly 5.38 or 83. Let me, I think 38, 5.38 MeV. So 5.38 MeV will be the kinetic energy of the alpha particle. Okay. And here option B will be the answer for this question. Okay. Now, question number 4. This question is also very important and very interesting question. So what this question is saying, the question is saying that the intensity of sunlight observed as 0.092 watt per meter square. Okay. Excuse me. So the intensity is given. Intensity of the sunlight is given at certain point in the free space. Watt per meter square. Excuse me. What will be the peak value of the magnetic field at that point? So this question is also very important and very common in various competitive exam. So students, you have to remember a simple formula for solving this problem. What is that? So intensity is equal to energy density into C. So this is the formula you should remember. What is this energy density? This is either electric energy density or magnetic energy density. That means you need to write U is equal to either half epsilon naught E square. This is the electric energy density. Or if you need to find out B, then you have to write half B square or B naught square here. B naught square by mu naught. So this is the formula that you need to remember here. Okay. So let us go with this second one because I have to find out the magnetic field, peak value of the magnetic field or B0. So look here. So intensity. So if I write this as half, okay, 1 by 2 mu naught, and this is B naught square into C, that is equal to I. So what will be B naught? B naught will be 2 mu naught I divided by C whole square, right? So you can do one thing. You can either use the value of, okay, let us use this value of mu itself. So if we use the value of mu, so this C is actually speed of light. Mu is 4 pi into 10 to the power 10 to the power minus 7. Okay, what is I'll just write here as I itself divided by C, that is 3 into 10 to the power 8 meter per second. Okay, so let us go to the next page to complete this calculation. So B0 will be equal to square root of 2 pi 2 into 4 pi 2 into 4 pi into 10 to the power 15. Let us write 10 to the power minus 15 into I is 0.092, I guess. Yes, 0.092 watt per meter square. And in the denominator, then I have only 3. Only 3. Now look this, I can actually further do certain simplification for my sake of calculation. This pi I can take as 3 itself. Let us write this as 4 into 2, and this I'll write 92 into 10 to the power minus 3. That will add up to here. This will be 18. Okay, so further I can actually do the simplification. See this 4, see what it will be. This will be 46 into 2, right? Yes. So 2 into 2 into 4 into 46. 46 into 10 to the power 10 to the power 18. Okay. So this will be actually, see this from here, 1 2 will come, from here 2 will come, so 4 root over this into 10 to the power minus 9. Okay. So here if we just approximately take this as 79, so 79, that means we'll get something like 7, so nearly 28. And from here 110 I'll take here, so this will be 10 to the power 8, so it will be nearly 2.8 into 10 to the power minus 8. In that will be in Tesla unit. Let me check here some options. Yes, look, I did not do the exact calculation, so I am actually near to this value. So this is actually the correct answer for this question. Okay, so 2.8. See, another power was there, 10 to the power minus 8, but this is nearly 2, but I have got nearly 2.8, so which is matching with the option. All right guys, so please keep this formula in mind. I is equal to U into C. So either magnetic field or electric field you have to find out, amplitude of the electric field or magnetic field you have to find out in the course, like in the exam. Okay, using this formula. All right, so let us go to the next problem. Sorry, I'm sorry. I think the last question or last 2 3 questions is not saved in this. I'll write the questions and we'll try to solve those. So what is the last question? Last to last question is, what will be the average value of question number 5? What will be the average value of energy for a monoatomic gas in thermal equilibrium? Thermal equilibrium at temperature T. Thermal equilibrium at temperature T. Okay. Options are given here. First option says it is 3 by 2 kBT. Kb is the Boltzmann constant. Option B says it is half kBT. Option C says it is kBT. Option D says it is 3 by 2 kBT. Okay. So how to find out this question? Like answer. The average energy means somewhat internal energy of a gas. Okay. So what is that formula of internal energy? So you know internal energy is actually N into or let us write F into half kBT. Half kBT. So what is this F? F is actually, let me change my color of ink if possible. Yes. Yes. So this is the formula for internal energy or average kinetic energy also you can say at a particular temperature. What is that? That is F into half kBT. What is F? F is degrees of freedom. Okay. This is degrees of freedom. Okay. So F is degrees of freedom and kBT, half kBT is the energy associated with each degrees of freedom. And this will give you the total average energy of the gas. So monoatomic gas where am I? Yeah, monoatomic gas. So what is the degrees of freedom of a monoatomic gas? We know degrees of freedom will be F is equal to 3n minus L. L is the number of constant. So monoatomic gas, it is free to move in 3 dimension, right? And see how much. So that's why 3, and n is the number of atom in the molecule. So that is 1. So 3 into 1. And what is the constant? Constant there is 0. There is no constant for this. So it is 3. So what is the average energy then? Average energy. So the average energy will be F is 3, right? So 3 by 2 kBT. So this is how we have to solve this problem. Okay. We'll take a few more questions. Let me write the question here. So the question is, A bullet of 4 gram mass. Excuse me. So before I write, let me change the color of the ink. Question number 6. This question says a bullet of mass 4 gram mass is fired from a gun of gun of 4 kg. Okay. If the bullet moves with the muzzle, if the bullet moves with the muzzle speed of 50 meter per second, the impulse imparted to the gun, velocity of recoil. So you have to actually find out two parameters here. The impulse imparted to the gun and velocity of recoil of gun are, so there are four options. 0.4 kg meter per second and velocity is 0.1 meter per second. Okay, and option B says it is 0.2 kg meter per second, 2 kg meter per second, and velocity is 0.05 meter per second. Option C says it is 0.4 kg meter per second and velocity is 0.05 meter per second. Option D says it is 0.2 kg meter per second and it is 0.1 meter per second. So we have to solve this problem. Before solving, let me read out the question once again, the full question. A bullet of 4 kg mass is fired from a gun of 4 kg, 4 gram mass is fired from a gun of 4 kg. If the bullet moves with muzzle speed of 50 meter per second, impulse imparted to the gun and the velocity of recoil. This question is actually very simple. Okay, so how to solve this problem? We have to solve this question by law of conservation of momentum. Okay, suppose I write, so there is a gun, suppose, this is the bullet. It comes out of this gun and moving with the velocity small v, and it has mass small m, and it recoils with the velocity capital V, and it has got mass capital M. So I can write initially both were at rest, so I can, from the momentum conservation, so from the conservation of momentum we can write, sorry, I just want to change the ink. Okay, yeah, so initial momentum was 0, final momentum will be mv plus small mv, right? So what does this mean? This mean, this mv, so both will actually move with the same momentum in the opposite direction, so that total momentum becomes 0. Okay, so this is actually the fundamental concept here. Now the bullet is actually moving with marginal speed. That means what? That means the speed of the bullet minus the speed of the gun. This is the marginal speed. Okay, I'm sorry, this is the relative speed of the bullet, say. Okay, marginal speed is given 50 meter per second. Okay, actually what we can do, we can find out. So the question is, what is the impulse imparted to the gun? Impulse imparted to the gun, and what is the velocity? We have to actually find out what is the recoil velocity. Let us find out this one, and we'll take the magnitude of that. Okay, small mv by capital M. Okay, so what is small m? Small m is 4 gram, right? So 4 into 10 to the power minus 3 into 50 meter per second divided by m is actually 4 kg. That means 4 into 10 to the power 3. Okay, 4 into 10 to the power 3 kg. It's 3 gram. 4 kg. Okay, I'm just making both 4 kg. Let us view this itself. So look here. From here we will get the velocity of recoil. So what is the velocity of recoil of the gun? That is 15 to 10 to the power minus 3 meter per second. That means what? That means 0.05 meter per second. Okay, then what will be the impulse? Impulse will be mass of the gun, that is capital M, into this capital V. That is the impulse imparted to the gun by the bullet. So 4 into 10 to the power, 4 into 0.05 meter per second. This is 20. So 0.2 kg meter per second. We have to check the options. Yes. So the option B will be the correct answer for this question. So 0.2 will be the 0.2 kg meter per second, and this is recoil velocity. Okay. So this is how, see, conservation of momentum is actually giving you the answer here for the recoil velocity as well as the impulse imparted by the bullet to the gun. All right, we'll take one more question. Let me change the ink. So question number 7. The question we are going to take now is also very, very important. So the question is, a potter leaped let me write the question. A potter leaped a heavy suitcase of mass 80 kg and at the destination lowers it down. So it leaps, like the potter leaps at certain point, and at destination it is like actually he puts it down, and the distance is actually, sorry, put down by distance 80 centimeter with a constant velocity. Then you have to find out the calculate the work done by the potter in lowering the suitcase. Okay, so you have to find out the work done. Okay, so there are certain options, 4 options: 6 to 7.7, sorry, 2 joule. Option B, -6 to 7 to 0.0 joule. Option C is positive 627.2 joule, and option D is 784.0 joule. So dear students, before we solve the problem, always better to read the question once again properly. So a potter lifts a heavy suitcase. The question says suitcase of mass, the destination lowers it down by a distance 80 centimeters with a constant velocity. So this he does with a constant velocity. Now you have to find out what is the work done by the potter in lowering the suitcase. So here we have to solve this problem from the conservation of energy. See, he does it with a very constant, like constant speed. So here actually work done is happening by two agencies. One is work done by the porter, sorry, work done by the porter. Let me change the ink. So work done by the porter plus work done by the gravity, okay, or the weight. We can say there are two forces here, and since it was lifted from ground and kept it down, so change in the energy will be actually zero. Okay, change in the energy will be zero. All right. So from here, what we get? W Potter is equal to WG, right? So that is, see, 80 centimeter into, here the question was, see, the G you have to take as 9.8 meter per second square. So this will be actually lowers it down by a distance 80 centimeter. This is actually not a distance, lower it down by 80 centimeter. Let me see. Okay, actually this is not a distance. First of all, this is lower it down by 80 centimeter. That means this means actually the height. Okay, this is actually height. And see, I'll just try to demonstrate it a little better way. Let me tell you what it has been done is, like, see, this was lifted, some weight has been lifted up to some height. Okay, so let us say from the ground to some height h, or some height, we don't know that. And actually he is not putting down totally to the ground. According to the question, it is actually putting down up to certain height. This is 80 centimeter. Okay, I think this is the better understanding of the question. And it is done with a constant speed. That means, the speed here is v, here is also v. Okay, with constant speed, that means there is no change in the kinetic energy. That is why there is no change in the kinetic energy. Okay, this is the understanding. Okay, now this distance, if I take from here to here, this height, so I take as a minus height. Okay, so mgh, it will be actually minus mgh. M, we know the weight of the, okay, didn't I write the weight? Heavy suitcase of mass 80 kg, right? It is 80 kg. Okay, so 80 kg, so m is 80 kg, then j is 9.8, and further 80 centimeter, that is 10 to the power minus 2, right? So this two will cancel this 10 to the power minus 2. So I have got 9.8 into 10 to the, sorry, into 16, 8. So this is 1, is okay. So what are the options? 6 and all are there, right? So did we do some mistake? mgh, so this is what it is. Okay, let us do the multiplication properly. Okay, so this is with 16. Oh, I see. This is 8, 8 is 64. I'm sorry. Okay, so once you do this multiplication, I'm writing the direct answer itself. So if you multiply this and do the calculations properly, you must be able to get this as minus 627.2 joule. Okay, so this is the answer for this question. And see the option given here is this one. Option A will be the correct answer for this question. So thank you for your patience. Bye for today.